So this is the last lesson, last chapter on polar and rectangular forms of equations, and then how to graph A r equals AB sine theta. In this video, I want to show you why do we even have to why learn polar coordinates. So I'm taking a problem straight away from used in real life. So this is a problem on. Before I go to this problem, let's just recall what are we supposed to know is this grid that you see is a polar grid where you have a polar axis. So this is the polar axis. Okay, and then you can see those concentric circles at a distance, let's say 1 and 1, 2, 3, and so on. And any point in this grid, let's say this is the point. This point can be identified not by xy, but we are going to use how far away is this point from the center here, and how much does this point, if along this line, let's see, along this dotted line makes, and what angle does it make with the polar axis? So this line is a fixed line. So that's how we figure out. So r equals sine theta. Now in this example, you will see that this is pi by 6, this is pi by 6, this is pi by 3, this is pi by 2, and then this is 2 pi by 3. This point is like a pi by 6. Then you have pi, and so on. This will be 7 pi by 6. This will be 4 pi by 3, and this is 3 pi by 2. 3 pi by 2, and this is 5 pi by 3, and this is 11 pi by 6. Okay, so the question is, if you know how far away from this, and then we use they are called polar coordinates written by r comma theta. So r is how far away from here, and theta is nothing but is the angle that is made. Then the question is, we know that x, suppose this was x. If this was x and y from parametric equation, that x, remember any point on the unit circle or any circle with radius r, suppose this was the circle with radius r, right now it is 4, just imagine it is 4, then x is all, for the unit circle it is r equals cosine theta and y equals sine theta, but if it is some distance other than 1, then it is r cosine theta. You can clearly say this is x, so the other way is this is x and y. This is not exactly x and y. I mean these when you write x, y, these are rectangular. So these are rectangular coordinates. These are polar coordinates. It's not that r is x. No. If this is x, look, I watch this. This is x, and that is y. So we can use Pythagorean theorem and say r square is x square plus y square. So there is a relation between rectangular coordinates, that is x, y, and the distance, that is r square is x square, y square. And the angle that you see is the opposite adjacent, and you can write it that theta equals tan inverse yx. Then my goal for this part is just want to use x equals r cosine theta and r sine theta. So let's see how to use this. Okay, an air traffic controller radar display. So the radar display detects a passing plane. Now this is an airplane. Okay, this is the airplane. That means a plane flying at an angle of 285 counterclockwise from the north at a distance of 3 miles from the radar. Now what does this mean? So what I did make a grid right there. It means this is the north, that is separate kind of a rule for this. So they said not from the x-axis. See, when we talk about the polar, when I talk about the if any angle, when you say any angle theta, the coordinates here is r cosine theta and r sine theta. So what is that? Theta basically means how much the angle makes with this one. This is the x-axis. So that's the theta difference. But here this angle which is given to you right now is 285. That means from this part 285, and it is at north, from north, so this is a very important, at a distance of 3 miles from the radar. It means, now this is like a 1 mile, 2 mile, 3 miles. So anywhere you go, it's like 1 mile, 2 mile, 3 mile. Anywhere, 1 mile, 2 mile, 3 mile, 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 and so on, right? So now we want to know what is 285. So 285 will be, now remember from, if I start this as the 0 angle, okay, that's the 0 angle. This becomes the 90 angle, we are going to 0, and then this becomes 180 degrees, see? Confusing, right? So 0, 90, 180, and then it says 285. So if this is 180, where is 285? So you can add 180, so this will be 285 from here. Yes, did I copy it right? So yeah, that's 180 plus, let me check the question and whether I copied it correct. 285, 3 miles. Oh, okay. Okay. So sorry. this is 180, right? I confused you. What's this? So from if this is the 0, then so from north this will be a 90. So this is going to be, this part is going to be 90, then 180, then 270, and how much more is 270 to 285? And you can see 285, and if I subtract 270, you get 50. That means the angle at a distance of 3, so I have to plug in where is 3. So I'm gonna, 15 will be somewhere, this will be 270, and then a little adding 15, so somewhere here. So this how far should I go is this part. So the plane here, let's call this as P. The point is P, and we can write the coordinates of this point. So this is 3, this whole thing from here to here is 3, and the angle is, so even though this angle is 285, but for us, if I want to write the polar, in order to write the polar coordinates, I want to know what is that, what is that r theta here. So the r theta will be in the form of rectangular coordinates. We can write also, you know, it is r. So this is r cosine theta and r sine theta. Now what is that theta? Right now is not 285, but this angle, that is 15 degrees. Makes sense? Okay. So that means P, so let's write it. P is, so, which you have to, so these P, when you write like 3, which is 3, and the angle is 15 degrees, these are polar coordinates, but I want to get rectangular coordinates. So what is the rectangular coordinates? That means I want to know what is x and y. So this will be for rectangular coordinate x and y. So this is r cosine theta, r sine theta. So now, so the P will be r is 3, so you can see clearly it is 3, and the angle is 15, so it becomes, so 50, sorry. So it is 3 cosine of 15 degrees and 3 sine of 15 degrees. So that takes care of the first one. But the second one is 30 seconds later, the plane is detected at 225. I'm going to show this one and then we'll put it together. 225, the plane is, no, so this is again 90, this is 0 from north, this is 180, and this is, this becomes 90, this is 180, and this is given to you as 225. So from 180 plus how much? So from this 225, this will be the point Q. So this is 2, because it is 2 miles from here and the angle is 220, so this is 225. So that means I call this as Q. So Q is 3, and remember the trick here is 225 is from here, but there is this part is 90, see? So that is what you have to take care. So you're going to add 225 plus 90, which will give you 315 degrees, right? So the angle here is, even this is 225, but we want the angle all from here to here. That changes to 350. So your theta is 350. So I'm going to write here, so 3, and the angle is 350. So these are polar, and then the Q in the, so this is 2, right? Because that's given 2. So I'm going to write 2. So the rectangular coordinate will be 2 cosine 315 and 2 sine 315. So these is, now you have 2 points. So P, let's put it together. So this point I'm going to put it right here. So this whole thing I'm going to put is, this P is right here. So there was one more. So in the beginning, this was the point P, okay, and now the point is Q. So this was 3, and that was. So just want to make sure we get that clear. So hope that helps. So this angle is 15. So the original was 15. So that's like if I want to write right here, it is like 3 cosine 15 and 3 sine 15, right? So if I want to write this point, so this point will be, this is 2, right? So it is 2 cosine, now it is 315, and 2 sine of 315. Okay, so then we need to write what is the distance from, how far away is this point from P to it? We want to know how much is this distance. So the question here is figure out plane speed in miles per hour. So the speed is, what is speed is distance divided by time, and the distance is what we have to find out. We know that this is x2 minus x1, the whole square y1 minus y2. So we can use that, and the time is given you. So the t, which is the time, is given to you in 3 seconds. So this is very important, in 3 seconds. So 3 seconds, you need to convert this into a degree, into hours. So 3 seconds, I can change it to in 1 hour. Let's see, in 1 hour there are 60 minutes, and every 60 minutes is 60 seconds. So it's like 60 times 60 is 3,600, and that's in so many seconds, and you can cross this out. So your t becomes 3 and divided by 120. So this 3 goes, I mean, it's 30 seconds. I missed that 0 here. So one of the zeros goes away, and 3 divides 1 and 2 zeros. So you get 120 of an hour. So this is very important because we have to plug it in over here. So first we use x2 minus x1. So this point is like x1, y1, and this is the point x2, y. So we want to know how far away is this point x1, y1, x2, y2. And then just use the distance formula. So PQ is square root, and you can use this x1. See, it is 3 cosine 15 minus 2 cosine 315 square root plus, and this 3 sine 15 minus 2 sine 315, and then square. And this is what you have to plug it in the calculator. So if you put this on your n-spire calculator, I did the work here. So you just plug it in and you get an answer as 2.6457.531. So I'm going to take this point, and then finally you want to know what is the speed, right? So we want to know speed here. What is the speed? And speed is distance over time. So let me write it here. So the speed is distance over time, and this is the distance which is in miles. So we'll write that for 2.6457531, and then divide by t, which is 1/20. So keep change flip, that is the top one stays the same, the numerator stays the same, and you just multiply, 531, and this 1/20 will be 1/20 over 1, and you get the answer. You get is again, you can check in the calculator, you get 317.49 miles per. So the speed of the plane, so the air traffic notices that the speed of the plane is 317 miles per hour. I hope I made sense to you as why are we learning polar coordinates? What's the goal? Where does it use? And you can see air traffic controllers do use the radar that they have. They can see what location is the plane, how far away from the main position, and what angle does it make with the polar axis. Hope this helps, and in the next video I'll try to show some of the problem. How do we convert from the rectangular coordinates to polar coordinates, and also from polar coordinates to rectangular coordinates. So that we will see in the next video. Thank you, and thanks for watching. Hope it helps.